Welcome to AD Mathematics, and in this video we are going to look at rationalization of surds. Sorry for the interruption. We are going to look at rationalization of surds. Now, when we talk about rationalization of surds, basically it is the process of making the denominator of a fractional surd whole or rational numbers. The process of making the denominator of a fractional surd or surds a whole number or rational numbers. Now, notice, so let's take an example. The first one, we have 1 over root of 2. Now, when we talk about rationalizing this particular surd, it means we don't want the denominator to be a surd, or all that we want is that we want the denominator to be a whole number. Okay, now notice that anytime we have square root of a multiplying square root of a, we get a, right? So now, in other words, let's say I have square root of 3. If you want to make it whole, you can multiply by what? Another square root of 3, and then you get 3. 3 is whole or a rational number, right? So we are going to use this same idea. And in mathematics, you cannot transform, you can only transform, but you cannot change the exact solution of, I don't know how to put it, but whatever you multiply to the denominator, you have to do same for the numerator, right? So let's say solution, we have the first example, 1 over root of 2. Now we know that for we to remove this root of 2, or for we to make the denominator whole, we have to multiply the denominator by root of 2, so that when root of 2 multiplies root of 2, we will get 2, which is whole. But then the question is 1 over root of 2, and if we want to nullify this effect, we can bring another root of 2, so that this root of 2 will definitely cancel this root of 2, and hence we are going to have 1 over root of 2 back, right? So we've not changed anything. We've just, it's like shoot and leaving, adding and subtracting. Yes, so here when we multiply both sides by root of 2 over root of 2, what happens is that we can say root of 2 will cancel, this one can cancel this, and then we still have the same expression, right? So we've not done anything. Okay, so now let's move on. So let's do that. So root of 2 over root of 2. But here we are not going to cancel each other because we want to make this one whole. What we do is that we expand this. So numerator multiplying. So it's more like we are having a over b times c over b. What is our answer? We numerator multiply numerator, and then denominator multiply denominator. So we have a times c all over b times b, giving us ac over b squared, right? So it have the same thing happen here. So here we have 1 times square root of 2 all over root of 2 times root of 2. Okay, so what is 1 times root of 2? Basically, 1 times any number is that same number. So we have root of 2 over. What is root of 2 times root of 2? We have root of 2 squared. And per the rules of surd, when we are doing the multiplication, remember, I think it's here. Don't worry, you can refer. You are going to get root of 2 over. This one is going to give us 2. Okay, so have you seen you've been able to rationalize this one? Now, if you want to verify, you can punch this number on your calculator, root of 2 over 2. The answer you get compared to 1 over root of 2. So you punch this on your calculator. After that, punch this one also on your calculator and see if you don't get the same answer. Okay, so now I want us to solve more example of this form. So let's say I have 5 over root of 7, right? And I've been asked to rationalize. When I told you, when we say rationalize, it means we don't want to see that the denominator is instead. We want to see it is a whole number or a rational number, right? So here, what we can do is that, oh, don't worry. Let me add and subtract effect. So I can say, let me multiply both numerator and denominator by root of 7. The idea is that when this one multiply this, we are going to get whole. Hence, you've been able to rationalize, right? So here, when you add when you multiply both sides, you are not adding any number, or you are not changing the value of 5 over root of 7. That's what I want to imply. You don't change the value of 5 over root of 7. Whatever you do shouldn't change the final value of 5 over root of 7. That's the reason we say multiply both sides of the multiply and then divide. So the effect you introduce is the same as the effect you absorb. Okay, so here numerator multiplies numerator, denominator multiplies denominator. Sorry, we have 5 root 7 over, what is root of 7 times root of 7? Is 7. So we have 5 over 7 root 7. Okay, so you can solve more example on this. My emphasis is on the next one, this particular example. Okay, let's solve it. We have 1 over 4 minus root of 5, and then we've been asked to rationalize. Is this possible? Notice in the first example, we only have a single denominator, I mean a single number. So it was easier as compared to this one. So now what is happening? What can we do? Remember that anytime we have a surd, if you want to convert that, anytime we have a surd, when we multiply that surd by its conjugate, we transform that particular surd to have what? A rational number, right? Do you remember? So if you've forgotten, go and watch the video on conjugate surd. Yes, and we said anytime, let's say root of a um plus root of b is a surd, when you multiply by its conjugate, which is in the form root of a minus root of b, definitely you are going to get a minus b, which a is a rational, b is also a rational number. Hence you've been able to rationalize, right? Because the idea of rationalization is that we don't want to see the denominator having root sign. We want to see it as a whole number or as a rational number, right? Okay, so let's see. We have here we can multiply both sides. Sorry, we can multiply the numerator and then the denominator by the conjugate. So we have 1 over 4 minus root of 5 multiplied by, what's the conjugate of this? We have 4 plus root of 5, and then divide again, 4 plus root of 5. Notice this whole thing is not different. Let me change the pen. This whole thing is not different from whatever we have here. If you want to challenge, you can just say, oh, this one can cancel this. Just like in mathematics, you have a over a can cancel a to give you 1. So this can cancel this, right? But we don't want to cancel. We don't want to cancel. We don't want to cancel. Okay, because of the rationalization, right? So we have, let's multiply, numerator multiply numerator. We have, sorry, we have 1 times 4 plus root of 5 all over 4 minus root of 5 multiplying 4 plus root of 5. Are we here? Okay, I hope I'm not confusing you. We are continuing. So here the numerator will give us 4 plus root of 5, and then let's simplify the denominator. Well, there is a quick way of doing it, but for the sake of us, let's solve it systematically. Those of us who are weak in mathematics or who are very slow, yes, in fact, pretend to be slow so that you achieve higher accuracy. And don't rush or else you get it wrong. So let's expand this. We take the 4, we take this 4, and then we multiply by the whole of this. 4 plus root of 5, and then minus, we take this one, root of 5, multiplying 4 plus root of 5. 4 plus root of 5. Okay, so this is the same as, let me change the pen, the same as 4 plus root of 5 all over, what is 4 times 4? 16. What is 4 times root of 5 plus 4 root 5? right? Minus root of 5 times 4. 4 root 5 minus root of 5 times root of 5. What do you get? Minus what? 5, right? So notice, if I were you, you see 4 plus root of 5 multiplying its conjugate, 4 minus root of 5. One thing that you have to be certain is that it is always this times this. So 4 times 4 is like 16 minus this times this, giving you 5, right? Because the middle one, look at you. Here you have 4 root 5, here you have 4 root 5, they are cancelling each other. Okay, so let's move on with this example. We are still continuing. What do we get? We have 4 plus root of 5 all over 16 minus 5, giving us 4 plus root of 5 all over 11. Okay, and here, remember, when you have in mathematics, when you have A plus B all on C, it is the same as A on C plus B on C. Yes, so with this expression, we can also write it as, let me write it in white. You can also write it as 4 over 11 plus root of 5 over 11. Now notice in your final exam, sometimes in the WASI, you can be asked to express your answer in the form A over B plus C over D. So now you have to show us what is A, what is B, what is C, and what is D. And if you express it this way, definitely you are going to be marked fully, or you are going to get the full score. Okay, so this is all about rationalization of surds. Remember, I've already told you, if you want to understand it more, just be solving more examples from the textbook, from past questions, and shall be well. So this is the end of today's video. Please don't forget to share the video, like, and then subscribe. See you in the next video. Bye bye.